In this video, we will add, subtract, and divide radical expressions. Let's go over adding and subtracting radicals first. The first thing you need to do is you need to simplify where you can. After you simplify, you look at radicals just like they're like terms, and you're going to combine the like terms, which in this case would mean they have the same radicand, the number underneath the radical. It's just like when we have variables. If we add 3x and 4x together, we would get 7x. We wouldn't change that radical. But we do add the coefficients, but we leave the radicands the same. So in this example, 2 root 5 plus 3 root 5. The radicands are the same. They're both 5. So we know we can combine these. 2 plus 3 gives me 5, and then the root 5 stays the same. Here we notice we have root 7 and root 7, so they are like terms. So we can combine them. Negative 6 minus 3 is a negative 9 root 7. Let's do some examples. We have the square root of 8 plus the square root of 18. Notice that those radicands are not the same. 8 is not the same as 18. So we have to simplify the terms first. So the square root of 8 becomes the square root of 4 times 2, because 4 times 2 gives you 8. But then we can break apart these radicals into root 4 and root 2. Well, we know what the square root of 4 is. The square root of 4 is 2. So we have 2 root 2. That is the square root of 8 simplified. Now let's simplify the square root of 18. 18, the factors that we would want to use are 9 and 2. Remember, we have to pick factors of that number that 1 is a perfect square. So we have our 9 times our 2 that we can separate into the square root of 9 times the square root of 2, and that becomes 3 root 2. So instead of having the square root of 8 plus the square root of 18, we can have 2 root 2 plus 3 root 2. And now that we've simplified, we now have like terms, and this becomes 5 root 2. The next example, if we look at simplifying 12 root 3 and 5 root 2, both terms are already simplified. The root 3 does not simplify. The root 2 doesn't either. We are not trying to simplify the coefficients. We're trying to simplify the radicals. And root 3 and root 2 are in their simplest form. But notice the radicands aren't the same. 3 and 2 are not the same number. So those are not like terms. Both terms are simplified but can't be combined. And so our final answer is just that full expression, 12 root 3 plus 5 root 2. Next, we have 3 root 12 minus 6 root 27. They're not the same, so we simplify first. 3 root 12 becomes 3 times the square root of 4 times 3. Separate the radicals, and then take that square root of 4. But then we can multiply the 3 times the 2, and that becomes 6 root 3. So 3 root 12 becomes 6 root 3. 6 root 27, we separate the 27 into 9 times 3. We have 6 times root 9 times root 3, which becomes 18 root 3. So instead of writing 3 root 12, we're going to write 6 root 3. Instead of writing minus 6 root 27, we're going to write minus 18 root 3. Notice now that the radicands are the same. So 6 minus 18 is a negative 12, and we have our root 3. Next, we have 3 root 40 minus a negative 2 root 90. Simplify both of those terms first. So 3 root 40 becomes 6 root 10. Negative 2 root 90 becomes negative 6 root 10. So when we rewrite this expression, we'll have 6 root 10 minus a negative 6 root 10. Minus a negative becomes an addition. So we have 6 plus 6, which is 12 root 10. Notice that that radicand is not changing. It doesn't become 10 times 10 or 10 plus 10. We're leaving that radicand alone. All right. Here we have 2 root 9. That's going to become 2 times 3 because the square root of 9 is just 3. And that becomes just 6. 2 root 24. The factors that we want to use are 4 and 6 because 4 is a perfect square. And that becomes 4 root 6 when we simplify it. So when I replace that expression with what it's equivalent to, we have 6 plus 4 root 6. Notice that that first 6 is not underneath a radical, so those are not like terms. We can't combine those. So my final answer is just 6 plus 4 root 6. Next, we're going to worry about dividing radicals. So notice here we have the square root of a fraction. What that means is we can actually take the square root of the numerator and the denominator separately. So we can actually break that apart. So here we have the square root of 9/16. That's the same as having the square root of 9 over the square root of 16, which then becomes 3 over 4. So next I have the square root of 12 over 100, which will become the square root of 12 over the square root of 100. Notice how I'm just taking the square root of the top and the square root of the bottom. So now this becomes the square root of 12 over 10. But now I can simplify the square root of 12. I'm not done. So I have to keep simplifying until I can't simplify anymore. So the square root of 12 becomes 2 root 3, and I have over 10. Oh, but notice the 2 over the 10 could also simplify. 2/10 is the same as 1/5. So we're simplifying that to be 1 over 5, and we have that root 3 on top. The way we would say this is root 3 over 5. And that is my simplified answer from the square root of 12 over 100. All right, we have the next 3 examples. Negative square root of 81 100ths becomes negative square root of 81 over square root of 100, which is just a negative 9/10. Here we have negative 121 over 196. Take the square root of the top, square root of the bottom, and we get 11 over 14. Here we have the square root of 6 over 24. That becomes the square root of 6 over the square root of 24. But notice the square root of 6 and the square root of 24 aren't perfect squares, so we have to try and simplify. The square root of 6 doesn't simplify. None of the factors are perfect squares. 1, 3, 2, 6, none of those are perfect squares other than 1. So we leave that as the square root of 6, but the square root of 24, we could use the factors 4 and 6. So that becomes 2 root 6. Well, notice here, root 6 over root 6, that's really the same as 1. So we can reduce those away and be left with just 1/2. So the square root of 6 over 24 is really just 1/2. Now, notice that in that last one, we had the square root of 6 over the square root of 6, which was really just 1. So we could reduce that away and we could leave it off. But what if we were to multiply by 1? What would that do to an expression? So like if we have 4 times 1, that just gives us 4. Multiplying by 1 doesn't change the value. 4 times 2 over 2. I'm still just multiplying by 1. My 1 just looks different. So that becomes 8 over 2, which is still just 4. I really just multiplied by 1 here. So notice that multiplying by 1, no matter how the 1 looks, doesn't change the value of the expression. So what if we had a different number 1? What if that 1 looked completely different? What if that 1 looked like the square root of 2 over the square root of 2? That's really the exact same as multiplying by 1. So by the end of it, my answer should still be 4, and it is. It doesn't change the value of that original number that we're multiplying by. That's going to be really important as we do the next part. An expression is not completely simplified when there's a radical in the denominator still. So notice in this expression here, we have that square root of 7 that's in the denominator. To simplify this, we have to do what's called rationalizing the denominator. So we do that by simplifying the fraction as much as possible. This is as simplified as it's going to get. 5 over root 7, we can't do anything to it yet. The next thing we're going to do is multiply the simplified fraction by 1. But that 1 is going to look funny. It's going to look like what this radical looks like. So we're going to take that 5 over root 7, and we're going to multiply by root 7 over root 7. Notice that we're just multiplying by 1, but it's a funny looking 1. Now we need to simplify what's left when we do that. So 5 times root 7 becomes 5 root 7 on top. Root 7 times root 7 becomes root 49. So let's simplify that a little more. 5 root 7 stays, but the square root of 49 is just 7. Now that we've rationalized that denominator, we no longer have that square root symbol in the bottom. So that's what rationalizing the denominator is all about, is making sure we don't have that radical in the bottom. All right, so let's look at this one. We have 4 over root 3. So we're going to take that 4 over root 3, and we're going to multiply by our funny looking 1. Except this time, our funny looking 1 looks like a root 3 over root 3, because that's what the radical on the bottom is. So multiply straight across, we get 4 root 3 over the square root of 9, but the square root of 9 is just 3. So 4 over root 3, when we rationalize that denominator, looks like 4 root 3 over 3. All right, next. What do you think our funny looking 1 is going to be in this example? Well, it should be what that radical is. Square root of 6 over the square root of 6. That's our funny looking 1. So we have 8 root 6 over 6. Where did I get this 6? From multiplying the 6 times the 6 and taking the square root of 36. But am I done? Notice the 8 over 6 can actually simplify. 8 over 6 here gives us 4 over 3. I could not have simplified the 8 over 6 first because this 6 was underneath a radical symbol. So I couldn't have simplified this to 4/3 first. Don't try to do that. If it's in a radical down here, something would have to happen to that radical up here to be able to simplify it. And that's not what's happening. All right, last one. 5 over root 12. There's actually a couple ways to do this one, and we're going to do it both ways. The first way is just rationalize like normal. Take the square root of 12 over the square root of 12, multiply by it, and we get 5 root 12 over 12. I got the 12 on bottom from the square root of 144. But I can simplify the square root of 12. So when I simplify the square root of 12, I get 10 root 3, because the square root of 4 is 2, and it comes out and multiplies by that 5. And so I have 10 root 3 over 12. Notice the 10 over 12 simplifies to 5 root 3 over 6. The other way is to simplify the 12 first, to say we have 2 root 3 on the bottom. Then we would rationalize with root 3 over root 3. So then we would have 5 root 3 over 2 root 9, which becomes 5 root 3 over 6 when we multiply that 2 root 3. So we got the same answer, just 2 different ways.